Number 56. The average television is said to be on 6 hours per day. Estimate the yearly cost of electricity to operate 100 million TVs, assuming their power consumption averages 150 watts and the cost of electricity averages 12 cents per kilowatt hour. All right, so I'm going to run through this. Take a look at number 50. I went through a detailed analysis of how to think about costs, electrical costs, and all that stuff. All right, I'm going to bring in the formula that we used there that I developed. So total cost for the whole year here, all right, year, if I could spell that'd be good, would be equal to then the cost per joule of electricity. Okay, that's being charged by the utility, multiplied then by the total number of joules used over that entire year. So whatever you're trying to find the total cost of over whatever time period, you got to make sure you know then whatever number of joules you're using over that same time period. Okay, so this formula makes it nice and simple. We know what we need. Now we just got to go hunting and start finding things. So remember, as I just mentioned, that this represents the cost the utility charges, and they gave us here that value, but they gave it to us in kilowatt hours, right? They didn't give it to us per joule. So we just have to do a conversion. And we remember, hopefully by doing practice, that 1 kilowatt hour is equivalent to 3.6 times 10 to the 6th joule. So I can simply convert this now, right? I can get rid of the kilowatt hour and get joule down there. How? Good question. So 12 cents per kilowatt hour. All I now simply need to do is get rid of the kilowatt hour in the denominator, and therefore in my conversion I have to put in the numerator. I'm going to put joules on the bottom, and now I'm going to put my known conversion numbers on in. So 1 kilowatt hour represents 3.6 times 10 to the 6th joule. Notice kilowatt hour, see you later. And now we're going to be left with joules. So 12 divided by 3.6 times 10 to the 6th. So 3.33 times 10 to the minus 6th. Now that represents cents per joule. Now, you can leave it in cents per joule. That doesn't matter, but I'm thinking about, 100 million TVs and all this stuff. So maybe we should turn this cents into dollars. Right, so I'm going to do one more conversion here. I'm going to write cents on the bottom, dollars on the top, and there's 100 cents on the dollar. All right, 100 cents on a dollar. And therefore, we just have to divide that now by 100, and therefore subtract basically 2 from that exponent already. So that becomes 3.33 times 10 to the minus 8 now, dollars per joule. So this now will represent my cost per joule. That many dollars per joule. So that represents this piece. So we just found it. Now my job is to find now the total number of joules used over the entire year for all the televisions that are operating. All right. Maybe what we should do is we should look at a TV individually, right? Let's see how much maybe joules are consumed or how much energy is consumed by a single TV. Then we know we got 100 million of them. So if I found the energy for one of them, I just multiply it by 100 million. So let's do that, all right? So now we know that TV averages a certain power consumption of 150 watts. So let's write that down. And we know that it's operating 6 hours per day. So 150 watts over, not over like, I just meant throughout, all right, 6 hours, not division, 6 hours. Now what I had recommended in the other problems is think about a watt as a joule per second. Why? Well, because it is. A watt is a unit of power, and power is the measure of the rate of energy utilized per second. That's what it means. So instead of writing 150 watts, what I'm going to do is I'm going to write 150 joules per second. They are equivalent. And this is where the units, knowing the units, come in handy. The reason being is because, well, wait a minute. I'm thinking dimensionally. If I have joule per second here, and I have, by the way, remember seconds is time, and I have hours here, which also represents the time, which I could probably get into seconds, then I could probably cancel those times and be left with just joule. Oh, goodness. And then I'm already on my way to just knowing the number of joules, right? So let's do that. Okay, so let's take now the 150 joule per second. I want it just like this because I want the joules in the numerator. That's what I want to be left with. So now what I got to do is, we can do this a couple of ways. What I can do is I can convert this into seconds and then just plug it on in here. Or I can convert this instead from joules per second into joules per hour and then plug in my hour. It doesn't matter. We're going to have the same number of steps. So let me just do it in one nice little long conversion here. So I know that there's 60 seconds in 1 hour. See you later, seconds, right? Bye-bye. Now, if I stop the conversion there, I would get joules per hour. I don't want joules per hour. I want just joules. So now what I have to do is multiply them by the number of hours. In other words, 6 hours that this thing is operating, that this single TV is operating. So let's calculate. So we got 150 times 60. Oh, what did I do? Oh, that was silly, huh? What did I do? I just seen if you're paying attention, right? Did you catch me? I hope you did. Is there 60 seconds in an hour? Well, that's what happens when you wake up at 6:50 in the morning and try to do physics. There we go. Now. Okay, that looks a little better, huh? 3,600 seconds in an hour. So now let's do the multiplication. So 150 times then 3,600 times 6. Wow. So 3.24. 3.24 times 10 to the 6. And that is now joules. But you got to remember, what we did here was we calculated this for a single TV. Single TV. And also, don't lose sight of the fact that this is also a single TV over a single day, right? Because they were saying that it runs 6 hours per day. So in other words, you could have written down here 1 day. All right, 6 hours per day. So what we now realize is that this would have been then the total number of joules utilized per day, right? Now, wait a minute. They want to know how much the yearly cost is. So do I want to know joules per day or do I want to know joules per year? I'd like to know joules per year, right? So what we can do is simply take this number and then keep multiplying it. Or I can just plug in my extra part of the conversion there, all right? Doesn't matter. So why don't we erase this? And we'll just plug it on in, the extra little piece, okay? So this is again then going to be days on the top, year on the bottom, and there's 365.25, but who cares, days in a year. So the days go bye-bye, and now this gives me now the cost of running a single TV for the whole year, okay? So let's do it. So it's 150 times then 3,600 times 6 times 365. So this works out to now be, wish my calculator converted that into scientific. So 1.18, give me a second while I try to count this. 1.18 times 1, 2, 3, 4, 5, 6, 7, 8, 9. 9, okay. So that is now 1.18 billion. All right, joules of energy used for a single TV for the whole year. All right. Now what I need to do is take this. This is for a single TV, and now I got to find it for 100 million TVs. So what do you think we got to do? We just got to simply do a multiplication now, right? So what I'll do over here is do it on the bottom left. So it's 1.18 times 10 to the times 10 to the 9th joules per year for a single TV. So really, we could have written a little times or per TV on the bottom. All right. In other words, I could have done this whole conversion. I could have just written down joules per second per TV down here. The TV doesn't go anywhere, so the unit stays. I didn't draw it in because I think it looks a little more confusing. But it's down there. All right. Then what I can do is I can multiply that now by then the number of TVs. So they told us it was 100 million. Don't multiply just by 100. Make sure you plug in 100 million. Maybe just to be on the safe side, let's do that in scientific. So 1 times 10 to the 8. All right, TVs. So TVs go bye-bye. And this now tells me the number of joules that are utilized per year for all of the televisions. So let's multiply that by 1 times 10 to the 8. Why did I plug that into the calculator? Don't really know. So the answer here, I know why. because it's, what is it now? 6:57 a.m. Okay, so there's the number. So we got 1.18 times 10 to the 17th, and that's now joules per year. So this represents the total number of joules used over the entire year. Okay, so now what we're going to do is we're going to now simply take this value, which represents the total number of joules used for all the televisions over the entire year, and multiply it by that cost per joule that we found before. All right, so I'm going to do it on the top left. So total cost now will be equal to 3.33 times 10 to the minus $8 per joule. And then I'm going to simply multiply that now by my 1.18 times 10 to the 17th joules. Notice how the joules go bye-bye. And we're left with just dollars, right? So let's see what we get. So let's take that 3.333333 times 10 to the minus 8, multiply that then by our answer. And what do we get? We got a nice large value. So here we go. So it's 3.94 or so. 3.94 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9. Wow. $9 for all the televisions, right? We don't even need the dollar thing there because I have it, the dollar symbol. This represents $3.94 billion for a whole year to watch television for The Bachelor. Guys, thanks for tuning in. Appreciate it very much. Please remember to help us out and subscribe. And if you haven't already, tell your friends. We'll see you soon.